Okay, here we go. I'm going to review the slides. Yes. Yep. I'm going to review the slides that we already did. It won't take as much time as we did the first time. Okay. Okay, quiet, please. So now we got to learn how to. Hey, Jackie. Okay. Now we have to deal with when you're taking the square root or even the cube root when there's variables inside, because ultimately that's what this is all about, because we're in an algebra class. So remember, when you take a square root of a perfect square, those two operations cancel each other out. Right? Whatever it was that was being squared is what comes out. So the square root of x squared is x. The square root of x to the fourth is like saying the square root of x squared squared, right? Properties of exponents, says that's 4. And since the x squared is what was being squared, that's what comes out, right? The square root of x to the sixth is x to the third squared, properties of exponents. And since it's the x to the third that's being squared, that's what comes out. But ultimately, you're probably not going to be rewriting everything so it looks like a perfect square. You're probably just looking to see if that number is an even number, like x squared, then you're going to take that number and you're going to divide by 2, because 2 is the index of a square root. If you don't see it, but it's there. Like a cube root, you write the 3 to make sure we understand. That means cubed root. But if it's a square root, we don't put the 2. But still, 2 divided by 2 means 1x comes out. 4 divided by 2 means 2x's come out. 6 divided by 2 means 3. The square root of x to the 8. 8 divided by 2, 4. 10 divided by 2, 5. Yeah. Yes. Yes. Yes, it does. So then you can put these things together, which you could have some variables involved, but you could also have some numbers involved, right? So the square root of 4x squared, deal with the number first. The square root of 4, we know that's 2. And now we know that the square root of x squared is x. So just separate them like they're different problems. Right? The square root of 18, okay, 18 is not a perfect square, but we learned in the last class how you could use the calculator to like break that up. And we did that. I think we probably did an 18 in there somewhere. The square root of 18 is the square root of 9 times the square root of 2. And we know the square root of 9 is 3. So the only thing left is we got to put that x squared back in there. And so we get 3 times the square root of 2, but we've got that x that came from the x squared. Right? So we did all this on... Okay, we did all this already the other day. Okay. Yeah. Yeah. Like I say, do you understand the square root of 18, how we split that up? Okay, so I got 3 times the square root of 2. Do you understand how we take the square root of x squared? So we're just doing them both together. There's the x, and there's the 3 root 2. 3 root 2. Just think of them like 2 separate problems. Okay, we did this one in class. Remember the square root of 96 is one we had done on the worksheet that we had done in class. And that we knew already. 96 is 16 times 6. And the square root of 16 is 4. And then the x to the fourth, how many x's come out of a square root of x to the fourth? 4 divided by 2 is 2. And then we would always write it with, if there's anything outside the radical, you're going to start with the number, and then you'll have variables, and then you'll have whatever's inside the radical. Right? This square root of 6 you can't do anything with, right? 6 is not a perfect square. It doesn't have any factors that are perfect squares. So that's how you know you're done. Okay, then we got into, so what are you going to do if actually it's a variable raised to an odd power? Right? X to the third, 3 divided by 2 doesn't go evenly. So what did we do? Okay, well, let's split it up. X to the third is x squared times x by properties of exponents, right? 2 plus 1 is 3. So I can take the square root of x squared, that actually simplifies, and then the square root of 1x, I can't really do anything with that. So that's going to stay inside the radical. Right? The square root of x to the fifth, 5 divided by 2 doesn't go. Right? So I split it up. X to the fourth times x. And then how many x's come out of the square root of x to the fourth? 4 divided by 2 is 2. Right? If it's an odd power of x, you're always going to have a square root of x left over. Right? Because that's what has to stay behind. Because you can only take them out if there's an even number inside. And there's not an even number inside. So you're stuck. Yeah.
So like the bottom one says instead of 4 it says x squared times x would be x and power of x.
Can you say that again?
Like, you see how it says x to the 4th?
Yeah. Here?
If you change that to x squared, would the answer end up being x?
That's what that was. Then you get the x. Yeah. And I think we went ahead and did an x to the 7th then. Again, how are you going to split up the x's if you've got 7 of them? Make it 6 plus 1, you know. So it's always going to be the plus 1. And the square root of x to the 6th is x to the 3rd. So that one is simplified. Lose the square root when you do that. Right? Don't continue to write that. Which leads us to, what if you got more than one variable? Right? So you could think of each variable like its own little problem. Like x squared, y squared. Will we be able to take all the x's and y's out? I mean, are they even numbers? Yeah, they are. So we can take out an x and a y. Done. Okay, if it's x to the 3rd y squared, well, one of these we have to split up. But the other one, we don't, right? So just deal with them like they're separate problems. And then at the end, you can put everything together. Like this x to the 3rd, I rewrote it, x squared times x. And the y squared I left alone. And now I'm going to simplify factor by factor, right? The square root of x squared is x. The square root of x can't be simplified. The square root of y squared is y. Okay, now that's the answer. You know, it's more of a nicety than anything, but we can rearrange this to make it look like we want. We should put the things that are outside of the radical in front of it. So x times y, and then the radical goes last. Okay, how about x to the 3rd, y to the 3rd? You know, both of those had to be split up, right? X to the x squared x, y squared y. Take the square root of all 4 of those. You know, what's the last complication that we could get with this? It could be a number in there too. You could have like more than one variable, and you could have a number. All right. So I'm going to skip over this. These are the last couple slides that we didn't do the other day. So the square root of 25 x to the 5th y squared. So we should think of these like 3 different problems. But first it's the square root of 25, then it's the square root of x to the 5th, and then it's the square root of y squared. Can we take the square root of 25? Yeah, that's a perfect square, so I don't need to split that one up. How about the x to the 5th? So how will I split up x to the 5th? Yeah, x to the 4th times x. So, I mean, the way I usually do it is like this. I'm going to take one line where I rewrite all this stuff like this. 25 x to the 4th times x, I'm leaving space too, and then y squared. So that I can say, okay, this is the square root of 25 times the square root of x to the 4th times the square root of x times the square root of y squared. And now I'll go by factor, I will simplify. What's the square root of 25? The square root of x to the 4th. The square root of x. It's the square root of x. You can't simplify. The square root of y squared. Y. So that's it. And now just rearrange. Make that y go right there. So it's 5x squared y times the square root of x. That's how you simplify radicals. Okay? So how about this one? I'm going to look at this one. Look at this one like it's 3 different problems, right? Can I simplify the square root of 50?
No.
Okay, so how am I going to split that up? So remember how we do this in the calculator, because probably this is going to be the way you want to deal with numbers. Okay? Okay, so how do we do the square root of 50 using the calculator? Right, so on the first line, put x squared. This is a reminder. Right, on the next line, put 50 divided by x squared. Right, then you go to the table of values. And first thing is you're going to go down this list of perfect squares. Right? It's kind of hard. Somebody screwed that in. I got to unscrew that again. And look for 50. Do we see 50? It's going to go from 49 to 64. So at that point, you go over here and you go up until you find a non-decimal. Which is the first non-decimal? 2, right? So 50 is 25 times 2, and the square root of 25 is 5. So you could think of it like this, right? It's going to be whatever number's in the first column times the square root of whatever's in the third column. 5 times the square root of 2. Right? I'll take it in steps. Square root of 50 is the square root of 25 times the square root of 2. Right? How about the x to the 5th? How do I split up the x's? X to the 4th times x. How about the y? Y squared times y. Okay, now let's go through and put square roots over all of them. And we'll get 5 times the square root of 2. The square root of x to the 4th. X squared. The square root of x is the square root of x. Right? The square root of y squared. And the square root of y. Right? It's still the square root of y. Now put together everything that was outside the radical. 5, 2xy. Right? So that's the final answer right there. 5x squared y times the square root of 2xy. So try that one. Okay, go ahead. We done? Okay. So try that one. That's the last slide. Remember, if you look back, we did the square root of 96 already. Okay, could we take the square root of 96?
No.
How did you have to break up 96? What were the two factors? It's actually 16 times 6, right? And what about the x to the 7th? X to the 7th is x to the 6th times x. How about the y to the 10th? I'm not done yet. So y to the 10th is okay because it's an even number. Z squared is okay because it's an even number. So now I'm going to go down the line and make square roots out of every one of them. Right? Starting with the square root of 16, what is that? 4, not 8. The square root of x to the 6th. 6 divided by 2 is 3. Right? How about the square root of y to the 10th? Y to the 5th. The square root of z squared. Z. Okay, now we've just got to reorder things. What goes first? 4, x to the 3rd, y to the 5th, z, times the square root of 6x. That's it. So, I mean, you just have to be systematic about it. Be careful, be systematic. So again, we're going to give you a worksheet now to practice